Let's go ahead to page 3. All right, so starting at problem number 11, we have to find the domain, the range, the zeros, and the discontinuities. We'll hopefully recognize this as a form of a parent function to an extent anyway. It's a square root function. We always know that we're talking about domain and square roots that you cannot have a certain kind of number squared must be greater than or equal to 0 because you can't take the square root of negative numbers. Well, at least you can't take it and get real numbers. You get imaginary. So we'll go ahead and solve this. That means that 4 is greater than or equal to x squared. And we take the square root of both sides. So x must be, so let's do this, you get a plus or minus 2 here. And of course an or equal to. So now the question is, think about it. What happens to our inequality sign when we take square roots? Well, if you're not sure, the easy thing to do here is to know that if I put something bigger than 2 in here, I'm subtracting 4 minus, let's say, 9, which is no good. So you have to be between negative 2 and 2. So your inequality sign is actually going to remain the same. Square root of 2, you get the 2. When you get the negative 2, notice it did flip in direction. Okay, x is less than or equal to 2, just like x squared was less than or equal to 4. So here is our domain right there. As far as our range, we'll do this one, and we'll look at the graph as well just to confirm what we're doing there. But if you think about this equation, and I square both sides, I get this, and then I change it into this. Now, we should all recognize that from Algebra 2 last year, and from earlier this year when I mentioned you should remember it from Algebra 2 last year, as the equation of a circle. Right, a circle comes in the form x squared plus y squared equals radius squared. So this is a circle of radius 2 here. Okay, so let me get the calculator warming up here while so we can look at the graph then. But really what's happening here is the range, the lowest value you can have is 0, and the greatest value you can have is 2. Okay, this is going to be a half circle, and it's going to be the top half of the circle. And again, I'm going to show you that on the calculator here. Give it a little bit of time here. While we're doing that, we'll find the zeros of the function. In other words, we want to know when is 4 minus x squared equal to 0. Well, that's when is x squared equal to 4, and that occurs at plus or minus 2. And as far as discontinuities, this is half of a circle. There are none. Okay, it is continuous over its domain. See if our calculator is ready for us now. There we go, y equals, large screen, and let's do the square root. 4 minus x squared. You'll see it's the top half of a circle. Let me make sure my window's in good format here. 0 to 3 is fine. Actually, 0 to 3 is not fine because I go negative 2 to 2, so let's do negative 3 to 3. Get a good view there. Minimum we said was 0. The maximum we said was 2, so if I have negative 2, I'm going to go up to 4, and let's check this graph out. There you go, negative 2 to 2, 0 to 2 for your range. Okay, let's jump down then to number 12 where we have to evaluate each. So log 256 base 4. So this equals something. Let's call it x. So 4 to the x equals 256. Well, I know 4 is the same as 2 squared. So that's 2 to the 2x. And 256, I'm hoping, is a power of 2. So I'm going to count by 2's. 2, 4, 8, 16, 32, 64, 128, 256. You couldn't see me, but I was counting on my fingers. That's 2 to the 8th, in which case 2x must equal 8 and x must equal 4. Evaluated. Here we have, same deal, let's call this y this time. 3 to the y equals 27 root 3. 3 to the y, well 27 is 3 cubed. And don't forget, roots are fractional powers. And then don't forget, when we multiply like bases, we add our exponents. Okay, so that's 3 to the 3.5, or 7 halves, which means y is 7 halves. Okay, I'm going to scroll down. A couple things disappeared. I'll bring them all back a little bit later. Find the sum. Oops, I can't quite see where it goes to. Going from 1 to 12. So it starts at 1. That means I can use my formulas. This is in integers. This is 4 times the integers formula, which would be n times n plus 1 over 2. Minus, this is a constant, and this constant occurs 12 times. Minus 5 times 12. So what do I have here? 4 and 2 reduce. So I'm looking at 24 times 13 minus 5 times 12 is 60. Well, 24 times 10 is 240. 24 times 3 is 72. So that's 312 minus 60. Looks like a 252. So that would be A. Okay, number 14, terms. Find the first 4 terms. Well, to find the first term, I'm going to plug in 1. And that gives me 1 times 6 plus 3, which equals 9. D is out. A is out. Second term looks like it's going to be a 30. So, you know what? I'm going to cheat a little bit, and I'm going to find the third term now. Third term would be 3 times 18 plus 3, or 3 times 21, which is 63. So I'm going with B because this says 66. And you know what? I'm a little nervous. I get that way when I take tests. So I'm going to put a 2 in. 2 times 12 plus 3, or 2 times 15 is 30. They were both 30. Moving on to number 15, find the common ratio of the geometric sequence. Well, remember, go from one term to the next, we're multiplying. So to go from the next term to the previous term, I divide. So negative 6 over 15 divided by 2/3. Dividing by a fraction is the same as multiplying by the reciprocal. 3 and 15 reduce. Negative 6 and 2 reduce. So it looks like we end up with negative 3 over 5. Okay, and remember, you can always do the other way too. 18 over 75 divided by negative 6 over 15, which again will reduce when you multiply by the reciprocal. 15 and negative 6. So you have 18 and 6 reduced to a negative 3, and the 15 and the 75 reduced to a 5. So you have negative 3/5 both ways. And the last one on the page, number 16. We're looking at the pattern here. Looks like we're cutting in half, but the signs are changing, so we're actually multiplying by negative 1/2. So our ratio is negative 1/2. To find the sum of the infinite geometric series, we use our formula. S sub infinity equals the first term over 1 minus the ratio. So the infinite sum is 16 over 1 minus negative 1/2. So that's 16 over 3/2. 16 over 3/2 would be the same as 16 times 2/3, which looks like a 32/3. Which unfortunately is not on here, so I'm gonna double check my math here. Ratio certainly is negative 1/2. 1 minus 1/2 certainly is 3 over 2. I'm getting 32 over 3 here. Perhaps we have a typo. Not on here. I will double check that. Maybe I did some math wrong here, but we're going to end this video right now. Beginning of page 4, I will confirm whether or not this is an error on page 3, problem 16. We'll see you in a bit.